Hi everyone. In the given problem statement of trapping rainwater, we are going to given an n non-negative integer representing the elevation map where the width of each bar is 1 unit. Compute how much water it can trap after raining. So now even if I draw this diagram with the height at each levels, we are able to see that it is pictorially it's very easy for us to compute these values. For example, this is going to be 1 unit of water. Then here it is going to be another 3 units. And there it is going to be another unit which is going to be 6 unit. And let's say if the height is lower, then in this case, automatically the unit value is going to be decreased. Pictorially, it's very easy for us to define the problem statement, but the question arises, how do you do it programmatically? So in order for us to do it programmatically, we will have to use a formula, which is nothing but a very simple one, which is going to be minimum value of max of, means whatever the highest that is available. So let's say left or right minus height of that current index. So this would be the exact formula that you're going to apply. Now let us add, right? Let's say input. So here our input values are 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. I hope it's correct. Now on the right hand side, you have to calculate the max of left. So here, right, initially the value is going to be 0. So the max is going to be 0. And now we add that index 1. So what is the value previous to that 1? What is the maximum value previous to that current index, which is also 0? Now here the maximum value previous to this index is 1. Now if I come to the toward index, the maximum value is 1. Now the maximum value got changed to 2. The maximum value is again 2 out here, 2, 2. And from all these values, it is going to be 3, 3 and another 3. Then we have to find the maximum of right index. So you have to calculate from this side. So the initial value, which is always going to be 0. Then at the 2th index, the value is going to be 1. Now if I come here, the maximum on the right hand side from this current index is 2. 2, 2. Once we are at this index, right, the maximum value now would be changed to 3. And all the values from here are going to be 3. Now we have to calculate the minimum height. So the minimum height of 0 and 3 is going to be 0. Then 0, 0, 0. Here the value is going to be 2. These are going to be 1, 2. Here the maximum value is again going to be, minimum is going to be 2, 2, 2. Here the minimum would be 2, 2, 1, 0. Now based on these values, right, so if the value is basically the height, right, is 0, right, then there is no point, because let's say value minus, let's say whatever height be, then you're going to get an index of -1, for example. So in that case, you're not going to calculate that, because we are not going to be able to store the water in that case. So there is no point of calculating this. So the values that we're going to calculate, so here we are going to save 1 unit. So if I look into the 3rd index, right, here we are able to store 1 unit. Now means we are going to subtract, right, this is basically min of L comma R, and we have to subtract this value with the input. So all of them are, let's say for our case, right, we're taking it 0, because anything lesser than 0, it's negative, right? But we are not going to calculate those values, so we are going to take 0 only. So now after that, this value, right, so 1 minus 2 is going to be -1. So let us, for this time being, let us add 0. Then 2 minus 1 is going to be 1. 2 minus 0 is 2. 2 minus 1 is 1. Then 2 minus 3 is -0. Again 1. 1 minus 2, 0 and 0. So if I do a summation of this entire list, right, we are going to get a value of 0. 1 plus 1 plus 2, 4. 4 plus 1, 6. So the value is going to be 6. So we just have to calculate, you have to use this formula, which is the important formula, min of L comma R plus height. So let me type in the formula. Minimum of L comma R, left means lefter value, whichever values that are present, right, till that index, minus subtraction of h of that I index. So this would be the exact formula that you're going to require. So here, right, if we look into it, how many space complexity? So here we are going to require 2 space means or 2 arrays for us to compute this, and the space complexity is going to be higher. But if I look into how would be the time complexity, so to calculate this is going to be big O of n, then big O of another n, and then here you have to calculate it back. So it would be 3 big O of n, which is nothing but big O of n. So it would be a linear time complexity solution that we are going to come up. There is also another one, which is where we have to take 2 pointers and to calculate it. That would be a little bit easy or complex depending on how you want to look into it. For now I'm showing this solution, but if you want to deep dive and look into, right, what are the different other types of solutions that are available, feel free to explore. Now let us move to the Python implementation. Now let me initialize 2 values, max of left array, which is going to be having an initial value of 0, then max of right, which is again going to have a value of 0. Then we are going to create 2 more variables, max of left height, which is going to be 0, and max of right height, again 0, and the total sum of water that is going to get stored. So currently its value is 0. Now we are going to loop through it. So for I in range, so it's going to be 1 to length of height. So reason being, right, so this index is right, it does not matter what value it is going to be. Let's say it can be 9, but the previous height is always, we are assuming that is always going to be 0. So because of that we have initialized the value 0, and same we are doing on the right hand side, we are initializing the value with a 0 for this index. So its value is going to be, if height of the previous index I minus 1 is greater than the max of the left height. So in that case, max of left height is going to get the value of height I minus 1 and max dot left dot append max of left height, else we are just going to append the whatever the previous maximum height that was available. And similarly we are going to do the same thing for our right index. So here only one change that you have to do is that we are going to calculate from this indexes, because we have taken the value of 0 for this one, considering that there are no more indexes out there. So length, generally it's -1, but in case we are taking it from the second last one, so it's going to be -2. We are going to calculate till 0, so you have to give a value -1, and this step is going to be -1. Now here, because we are calculating this index, for example, so we are going to calculate the value which is present after it on the right hand side. So here, if height of I plus 1 is greater than the max of right height, in that case max of right height is going to be this value, and we are going to increment this to 1, and we are going to give a value of max right height, and we're going to append these two indices. Now if I look into the max of right height, right, because we are going to calculate from here, so our values should also be changed in a way. So we have to just reverse our max right height value. So in order to do that, max of right height, we are just going to reverse it, and now a simple another for loop which is going to be running from a range of height 0 to length of height. So we have to calculate, if you remember the formula, min of L comma R minus height of that index. So here we have to do water, create a temporary variable, so water stored equal to minimum of max left array comma max of right array minus height of I. So I have to type in the height. Now we have to just ignore the negative value. So if water stored is greater than 0, in that case sum of water is going to be plus of water stored, and at last we are going to return sum of water. Let's run the code. I hope it should work. Okay, I have to remove this one. Yeah, as you could see, the public test case is passed. So let me submit the code. As you could see, it is beating 43.29%, and our memory is also beating 43.84%, even though we have added 2 more lists in computing this entire program. So there is also, as I told you, there is another solution which is available where you have to use 2 pointers, but for the most time this is pretty efficient solution that you can easily use in your programming. That's all for this video. See you in the next one.